As Gail said, the topic of the talk is a spatial analysis that we've undertaken to try to gauge what the future potential of onshore wind is in Ireland. And as we approach this exercise, or the reason for the exercise was originally to deal with a matter of perception and perception versus reality, because over the last period of time there's been a view that there's maybe no more land left, or not enough land left, or that all the good sites are taken, or that there's just not sufficient potential left onshore to meet the future challenges in terms of what we need to do with where our future energy needs to come from. But what's the reality? And that's what this exercise was intended to try to figure out. So I'm going to talk just for a second about what I'm describing as the current policy bar, okay? And this is the bar that projects have to get over in order to make them viable and get them standing and turning and operating. And so the existing policy environment that we have and that we have had up to this point has gotten us to where we are today. So we have direct policies in the form of planning policies, grid policy, wind energy guidelines, refit and so on, that directly influence an individual in every specific project. And then we have the indirect policy examples, whether they be the scale of the government's ambition or political leadership in terms of support for renewables and wind, community support, EU policies and other national policies. And we kind of view these as either the headwind or the tailwind that the industry has to work with. But up to this point, there's been 4 gigawatts of projects that have cleared this bar, and they mightn't all be built yet, but we're thereabouts in terms of that number of projects that have gotten permission and are on their way to being built. There's probably another 2 or 3 gigs that will be able to clear the bar where it is at the moment, but I suppose what was curious from our perspective and from IWEA's perspective was, what else is out there if that bar were to be lowered? And how much lower does it need to go in order to meet the scale of the energy challenge that's ahead? So if the policy bar stays where it is, we might hit, or will be very close to hitting the 40% Res-E target by 2020. But at some point, if the bar stays where it is, we also will run out of land. And therefore, a different set of policies are going to be required for us as a state and a country to go as far as we need to go. So I don't need to remind people in this room about the scale of the challenge ahead in terms of the way that graph is going in terms of atmospheric CO2 and everything else that gives rise to. But I think based on some of the talks earlier this morning, as David Connolly said initially, it's not a case of, are we going to go beyond 40% Res-E? It's a question of how far beyond it are we going to go. And again, now we can't just think about Res-E, we have to think about energy. So really, the bar can't stay where it is given the scale of the challenge ahead. So I think there's 2 options to deal with the scale of the challenge, but also to deal with the opportunity that presents itself for a small energy market with an amazing wind resource, but also with world-leading levels of renewables being managed on the grid. And the 2 options are a clear policy ambition for onshore wind, as Mark Foley spoke about this morning in terms of when the 40% Res-E target was put out there initially. And that's one option where we could go again now, a very clear policy ambition to say this is the number that we need to hit. Or the second is a situation whereby we reach a limit by accident rather than design. So with all of the individual challenges that the projects we all work on face, if something doesn't change, we will hit a limit, or we will hit something that the projects can no longer get over. But really, the scale of the challenge is so important, the challenge is so important, and the scale of it is so big. We really, as a state, we can't allow that to happen. We can't allow ourselves to run out a road because we didn't look far enough ahead. So the question is, can onshore wind deliver, and if so, to what extent? So we set about an exercise which was essentially broken down into 4 steps and largely GIS based. And we use 4 different levels of information, and I'll take you through these individually. So there was a physical environmental constraints, there was housing and properties as a second level of constraints, there were existing wind farms or permitted and proposed wind farms, and then finally there was a capacity assessment. So in terms of the first level of constraints that I mentioned there, the physical and environmental ones, the study area that we looked at was the 26 counties of the Republic of Ireland. We can obviously look at Northern Ireland again as an add-on, but for now we stuck to the 26 counties. We identified what we consider to be just no-go areas, areas where, you know, in all reality, there's no point even thinking about putting a wind farm there. So this would include your ecological protection areas, so your Natura 2000 sites, your SPAs, your SACs, your NHAs, even your proposed NHAs. Rivers, including buffer zones around those, lakes, including buffer zones around those, small towns and a 2K perimeter or buffer zone around that, and then larger towns or cities with a 5K setback. And then national roads, we also identified and buffered, because again, you're not going to put a turbine right beside a motorway. Similarly with the rail network, and similarly with the electricity transmission network, given the requirement for setback there. But in terms of the criteria we used around these constraints, we took a higher level view than you would normally do at a site-specific level, because we weren't trying to design any particular wind farm in this instance. We were trying to get an overall picture of what the future potential might be. And you'll see in a second how we've brought some, you know, further clarity and reality to that. So these were the higher level constraints. We didn't consider the likes of, you know, archaeology. We didn't consider other, wind direction or site orientation like you would at a site design stage. So it was a relatively high level, but very clear in terms of these being no-go areas where we weren't expecting them to have any future potential. I think it's also important to just point out what we didn't consider. And what we didn't consider and essentially completely ignored was existing energy policy, wind energy policy, as might be contained within county development plans. We didn't consider landscape policy in terms of whether areas have already been identified as being of high sensitivity or low sensitivity. We didn't consider grid capacity in terms of whether you can get a connection within a reasonable amount of time, or is there capacity in the local network. And as I mentioned earlier, we didn't consider the sorts of constraints that you normally would when you're actually trying to decide on a turbine layout. And we didn't consider these simply because these are either policy instruments that can change, and I would suggest have to change, or they're technical constraints that can be dealt with. And again, they weren't considered relevant to the kind of what if question. You know, what if these weren't an issue and we wanted to see how much land was out there and what can that deliver. The second level that we worked on was in terms of housing and properties. And anybody that's tried to identify a site or design a project realizes how critical houses and our dispersed rural housing settlement patterns, how significant that is in trying to design and optimize a wind farm site. But we took a two-step approach here. We use the electoral division areas, which are the smallest legally defined administrative areas for which the small area population statistics are available. And within the electoral division areas, and you can see how many of them are there for the likes of County Mayo, within each electoral division area, we assessed the housing density. So if you were ending up or seeing more than 11 houses per square kilometre in any of these EDs, we believed that that was enough to essentially say there probably isn't going to be enough other land available on which to build a wind farm. Now, this is maybe quite a conservative view, because in one particular ED you might have a lot of housing on one side of the ED, and a number of miles over you might have plenty of room where you don't have housing. But we took this in or out, yes or no, above or below the 11 houses per square kilometre as the cutoff. And then within the electoral division areas where where the housing density was less than 11 properties per square kilometre, we mapped every single house using the air code data and buffered each of those properties by 600 metres. We picked the 600 metres because working off what's likely to be the 4 times tip height setback in the WEGs, the wind energy guidelines, we would give you 600 metres working off 150 metre turbine tip height, and obviously it's been turbines roughly up to 150 metres that have gotten us to where we are at the moment in terms of installed capacity. And it's not to say that turbines aren't going to get taller in the future, but that's been the reality up to now, regardless of what's coming in the future. So all of those properties were identified and buffered to see what lands remained. Then we had access to some IWEA data for existing turbine locations, because obviously if there's an operational project already standing and operating, that land is spoken for. But we also looked at any projects that are either proposed or permitted that have a contracted grid connection. And we did that again essentially on the basis that, well, if they've contracted their grid connection, that land is spoken for, and the capacity has already, or the potential of that particular site has already been identified. For every single existing turbine location in the country, or every proposed turbine location that's in a contracted grid connection, we then buffered those turbines as well, knowing that if you wanted to add on or extend or locate another wind farm beside an existing one, you were going to have to respect certain setback distances from those existing turbines. And finally, we undertook a capacity assessment. So we combined the 3 sets of constraints that I've just taken you through: the physical and environmental, the housing and property, and the existing wind farms. And the next exercise was to essentially look at what lands were left when all of those constraints were combined, and undertake then a subjective analysis. And what we mean by this is an analysis and a look at all of the areas to say, well, in good faith, even though the area has fallen through the sieve exercise and looks to not be constrained by everything we identified, are there areas where in good faith we shouldn't really expect to accommodate future wind farms? So, and again, this is open for debate in terms of what we selected or other areas that we could have brought in, but what we did run with were the lands on the seaward side of the Wild Atlantic Way, the UNESCO World Heritage Site around Newgrange and Brunabonia, the global geoparks, including the likes of the Burren and the Cliffs of Moher, key archaeological sites such as Clonmacnoise, the Rock of Cashel, and others like that. And then, I suppose what you'd consider to be the more renowned scenic landscapes, the likes of the Ring of Kerry, the Dingle and Beara Peninsulas, Connemara, North Sligo around Benbulben, and areas like that. So again, these areas were eliminated and ruled out and deemed not to be required to accommodate future potential sites. And then the last thing we had to do in this part of the exercise was run a small area filter. So we ended up with hundreds, if not thousands, of tiny little pockets of land all around the country, some of which were very isolated from other pockets, and bearing in mind the scale of the challenge ahead in terms of needing many more gigawatts, we felt if an area was only able to take 1 or 2 turbines, that's not going to cut it. And therefore, we selected a 1 kilometre square area as the cutoff, and again, we ruled out and deleted any areas that were less than 1 square kilometre in area. So that's the map that we were left with all the areas in green having come through that filtering exercise that I've just explained. And when you add up all of those areas combined, you get a theoretical viable area of 2,705 square kilometres, which is an enormous area of land. And I think if we were to develop that, we'd be powering the whole of Europe. But obviously that's not the intention, and we have to be realistic about how much of this can be converted from theoretically viable to viable in reality. Okay? So we set about trying to establish, well, what can you get, or what have people and developers been installing recently on projects? And we looked at current megawatt per square kilometre installed capacities by looking at 8 different 20 megawatt plus projects that were commissioned in either 2017 or 2018. These obviously would have been designed and permitted under the 2006 guidelines. We excluded 2 out of the 8 because they had a very high number, and the average of the others was 25 megawatts per square kilometre. Now, for us in the office doing this, that was an unusually high and an unexpected number, but what we did was, as you can see here, we drew boundaries around the outermost turbines on the sites. So we only considered the lands within that. So we weren't talking about the red line planning boundary, we weren't talking about the land holding boundary, we weren't talking about the site as such. We were purely talking and measuring the areas within the outermost turbines. We then needed to consider a conversion factor, and the conversion factor we consider to be the percentage of the theoretical area that you're likely to be able to realistically develop, assuming policy comes right and all the other things come right. But this conversion factor was intended to take account of the fact that you're not going to be able to secure landowner consent in every location you'd like to. You're not going to have the planning policy in every location that you might be able to secure landowner consents. You mightn't be able to get a feasible grid connection in all the places where the planning policy is right. And even if the planning policy is right and there's a feasible grid connection, you might fall at a planning hurdle for some other reason. And if you make it over all of those obstacles, you still got to find a route to market. So this is what I was talking about earlier. This is what we use to try to bring some reality to that very big number of 2,700. And you know, really, this, you know, there's no real science to this particular bit of it. But let's say if we just took 10% of the area as being potentially viable, and again, bear in mind, we've already ruled out the areas and eliminated the areas where we're saying we can't put a wind farm there, or we're not expecting those no-go areas to have any future potential. Okay, so we're if it was realistic or if 10% of those theoretical areas could be converted into actually viable areas, then I think we're in a pretty good place. So we just using those numbers, that conversion factor number and the total area, you know, we've just looked at 3 separate scenarios: a low, a medium, and a high. So in the table there, you're seeing the same theoretical area across the 3 scenarios. You're seeing a 5%, a 10%, which I mentioned in the last one, or a 15% scenario. And obviously that directly translates down into a more realistic area that might be available, again, if the policy comes right, okay? But in terms of the 25 megawatt per square kilometre number that I mentioned on the last slide, what that's going to be in the future is hugely dependent on what we see coming out in the wind energy guidelines in the coming weeks or months or however long that's going to take. Because, you know, with what's emerging in terms of turbine technology, that 25 megawatt per square kilometre number could well end up higher, as we saw on certain projects that have already been installed at higher numbers than those 25 megs per square kilometre, or it could be significantly lower if a very restrictive position is put forward in the wind energy guidelines. So this is the big uncertainty that remains at the moment, the future megawatts per square kilometre in terms of what a total megawatt figure might look like at the bottom of this table. But you can do the sums for yourself in terms of whether it's 15 or 20 or 25, depending on what what the requirement of the wind energy guidelines might be. But I truly believe that the future megawatt potential is only going to be limited by the ambition in terms of what we want to achieve. So with the required policy to convert just 10% of the theoretical potential into viable projects, and what I'm calling a measured update to the wind energy guidelines, there's significant future wind energy potential remaining. I think with the 4 megawatts that we're well on our way to having, with the 2 or 3, the 4 gigawatts that we're well on our way to having, with the other 2 or 3 megawatts which should be able to clear the policy bar in terms of where it is at the moment, I don't think it's unrealistic to think that we can go on to 8 or 10 gigawatts in total, or perhaps beyond that. So it certainly, from my perspective now, having done this exercise, it's a case that land is not the limiting factor. Land is not the limiting factor in terms of what we as a country can go on to do with onshore wind. Policy ambition is the limiting factor. And if the policy ambition is there to deliver significant further quantities of wind onshore, the land is absolutely there. So that's where I'll leave it. Thanks for listening.